Good morning, everyone, and welcome. I'm pleased to have the opportunity to speak with you today. Today's presentation is titled Reconciliation of Working Standard and Reference Standard in QC Analysis. We will explore how to effectively align these standards to ensure accuracy and consistency in quality control. Over the next few minutes, I'll walk you through the key concepts, challenges, and best practices related to this important aspect of our work. Let's get started. Let's talk about the importance of reference standard, or RS, and working standard, WS. These are absolutely critical for ensuring analytical accuracy in our testing processes. When we use RS and WS correctly, we can confidently trust our results. Reconciliation plays a key role here as well. It helps us verify the traceability of the standards we use, ensuring there's a clear record of their origin and usage. This process also helps prevent misuse or diversion of these standards, which is vital for maintaining integrity. Most importantly, proper reconciliation ensures that our assay results are accurate and reliable. And as you probably know, these practices are not just good practice. They are mandatory under GMP and data integrity guidelines. So, maintaining strict reconciliation and proper use of standards is essential for both compliance and ensuring the quality of our work. Let's start with the definitions. A reference standard, or RS, is an official and highly characterized standard, recognized by agencies like USB, EP, or WHO. It's the gold standard we rely on for accuracy. On the other hand, a working standard, or WS, is a secondary standard that is calibrated against the RS. We use the WS routinely in our day-to-day work because it's more practical, but we always ensure it stays aligned with the RS. The RS is reserved for qualification purposes, ensuring the highest level of accuracy and traceability. Now, moving on to the reconciliation principle, this is a core concept in our process. The key equation here is that the quantity issued should equal the sum of what is used, what remains as balance, plus any losses and discarded material. For this to work properly, it's crucial that everything is weighed accurately. We need to record these measurements contemporaneously, meaning at the same time as the process occurs, to avoid errors. And of course, all of these steps must be verified by QA to maintain integrity and compliance. By following these principles, we ensure our measurements are reliable, consistent, and traceable, which ultimately supports the quality and safety of our products. Let's walk through the life cycle of standards, which is a crucial process in maintaining consistency and accuracy in our work. It all begins with the procurement of the reference standard, or RS, which is the foundational material for calibration. Next, we move to the qualification of our working standard, or WS, against that RS to ensure it's aligned and reliable. Once qualified, the WS is used routinely in our testing procedures, but this isn't a one-and-done situation. Periodic requalification is necessary to confirm the WS remains accurate over time. And of course, when a standard expires or is no longer valid, proper disposal is essential to maintain integrity and compliance. Throughout this entire life cycle, each stage requires careful reconciliation to ensure consistency. This is where assay standardization comes into play, using a specific formula. WS potency, percent, equals the response of WS divided by the response of RS, multiplied by the RS potency. This calculation is key because it allows us to accurately assign potency to our working standards, ensuring our results are accurate and comparable. So, in essence, understanding and managing this life cycle helps us maintain quality and trustworthiness in our testing processes. Let's take a closer look at the standard consumption for this sample. We started with an issued working solution of 100 milligrams. Out of that, 60 milligrams were used directly in the analysis. After that, we have 38 milligrams remaining. Additionally, there was a small loss during handling, which accounts for 2 milligrams. When you add up the used amount, the remaining amount, and the loss, it totals 100 milligrams, which matches the issued amount. This step is crucial because any loss during handling must be justified and documented properly. It's important to account for every milligram to ensure accuracy and traceability. Now, moving on to WS standardization, we are given the RS potency at 99.5% and the peak areas for RS and WS. The RS peak area is 50,000, and the WS peak area is 49,500. To calculate the WS potency, we use the ratio of the peak areas multiplied by the RS potency. So the calculation is WS potency equals 49,500 divided by 50,000 times 99.5%. This simplifies to approximately 0.99 times 99.5%, which results in a WS assigned potency of about 98.5%. This process helps us assign an accurate potency to the working solution, ensuring consistency and reliability in our analyses. Let's walk through the calculation step by step. First, we take the ratio of the sample area to the standard area, which is 52,000 divided by 50,000. Then, we multiply that by the ratio of the standard weight to the sample weight, which in this case are both 10 mg, so that ratio is 1. Next, we multiply by the potency of the working standard, which is 98.5%. Putting it all together, we get 1.04 times 98.5%, resulting in an assay value of 102.4%. Now, it's important to remember that this result falls within our acceptable limits if the specification range is 98 to 102%. This means our sample is considered within the acceptable range based on this calculation. Moving on, I want to highlight that this example uses the working standard, or WS, for the assay calculation. The formula here is slightly different but follows the same principle. It compares the sample to a standard, adjusts for weights, and factors in the standard's potency. So, in summary, the key points are understanding how to perform this calculation accurately, recognizing the importance of the ratios involved, and knowing that the final value needs to be within our specified limits to ensure quality and consistency. Let's take a look at the acceptance criteria for our process. First, the balance must match the issued quantity exactly. This is crucial to ensure accuracy and accountability in our inventory. Moving on to losses, these are typically very low, usually around 1 to 2%. It's important to monitor these closely because higher losses could indicate issues in the process. Regarding potency, it must meet the specified qualification criteria. Consistent potency ensures the quality and effectiveness of our product. Now, if there's any discrepancy between these points, whether in balance, losses, or potency, that's considered a deviation. Recognizing deviations early helps us maintain control and ensure we stay within our quality standards. Overall, these criteria form the foundation of maintaining product integrity and meeting regulatory expectations throughout our process. Let's talk about deviations and investigations. When we encounter deviations, there are specific triggers we look out for, such as missing standards, excess consumption, or incorrect potency. These are key indicators that something may be off in our process. When such triggers occur, our actions are crucial. First, we reweigh and verify the materials to ensure accuracy. Next, we review the audit trail to understand what happened and when. We also generate deviation reports, in line with 21 CFR 211.192, to document and investigate thoroughly. It's important to remember that no data can be released without proper closure of these investigations. Ensuring these steps are followed helps us maintain compliance and quality in our processes. Now, let's talk about the documentation requirements that are essential for maintaining data integrity and traceability. First, we have the standard issue logbook. This is where all the details about equipment issues, maintenance, and repairs are recorded consistently. It's crucial because it helps us keep a clear record of equipment history. Next, usage records are vital. These documents track how and when equipment or materials are used, ensuring we have a complete picture of operations. Then, we have standardization reports. These reports demonstrate that our procedures and processes are consistent and meet required standards, which supports quality and compliance. Finally, Analytical raw data forms the foundation of our data integrity. All raw data must be accurately recorded and preserved because it directly supports the reliability of our results. Remember, all these documentation elements must follow the ALCOA plus principles. That means data must be attributable, legible, contemporaneous, original, and accurate, with additional attributes like complete, consistent, enduring, and available. Traceability to the RS, or the reference system, is also critical. This ensures every piece of data links back to its source, making it possible to verify and audit the data seamlessly. So, in summary, thorough documentation, adherence to ALCOA plus principles, and clear traceability are the backbone of trustworthy data management in our operations. Let's talk about some common challenges we face in our measurements. One major issue is hygroscopic standards, which can lead to weight variation because these materials tend to absorb moisture from the air. This not only affects accuracy, but also consistency over time. Another challenge is potency degradation. Some compounds lose their strength as time passes, making it tricky to maintain accurate results. We also encounter micro-weighing errors, which are tiny inaccuracies that can significantly impact our data, especially when dealing with very small quantities. Additionally, frequent handling can cause losses, whether through evaporation or sticking to tools, which again affects the reliability of our measurements. Now, to address these challenges, we have several mitigation strategies. First, controlling storage conditions, specifically temperature and humidity, is crucial. Keeping standards in a stable environment helps prevent moisture absorption and degradation. Using a microbalance is also important. These are designed for high precision and help reduce weighing errors. Lastly, minimizing exposure time during handling and weighing can significantly reduce losses and improve accuracy. By implementing these strategies, we can ensure our measurements are more reliable and consistent, aligning with our overall goal of maintaining high-quality analytical results. So, in conclusion, RS and WS reconciliation really are critical for ensuring the reliability of our analysis. When we do this properly, we can confidently produce accurate assay results, which are essential for making sound decisions. It also helps us maintain data integrity and stay compliant with regulatory requirements, which is absolutely vital in our industry. Remember, having a strong standard operating procedure combined with precise tracking creates a robust quality control system. This foundation helps us catch issues early, maintain consistency, and uphold the highest standards in our work. Ultimately, these practices tie together our entire goal of delivering reliable, compliant, and trustworthy data. For further support, please feel free to contact us. We're here to help with any questions or additional information you might need. And with that, I want to sincerely thank you all for your time and attention today. Your engagement really makes this all worthwhile, and I appreciate your interest in this topic. Remember, we're committed to supporting you as you apply these insights. So, don't hesitate to reach out if you need anything. Thank you again for being part of this presentation.